Hello everybody and welcome to Lecture 8 for Forensic Science, Intro to Forensic Science for the spring 2018 semester, the winter quarter 2018, sorry I'm a little bit messed up today, at Midwestern University College of Pharmacy. This is recorded as I'm out of town, but we will continue obviously our discussion as used to in the course, and as I announced before, this is an online lecture and we will be talking about the extraction of naturally occurring drugs of abuse and potential signs of abuse. So this is an important issue in forensic science. And it relates a little bit to what you are doing, because some of the, not necessarily the naturally occurring substances of abuse, but especially some of the drugs that are being sold in pharmacies can be extracted through very similar processes. Dextromethorphan is a great example. Ephedrine formerly were used to be extracted via very similar mechanisms, via very similar techniques. So we're going to touch on that in this lecture. We're going to meet next week as usual on February 13th, Tuesday. And then the same week on that Friday, 2/16th, will be the final exam. For that 2/13th, there will be a half-hour lecture on limitation and or prevention of illicit drug abuse and trafficking. It's only a 30-minute lecture that usually would be given together with lecture 10, where also the final exam would be given. Final exam is a take-home open book exam, as you know already, but during lecture 9 we'll go a little bit into organic synthesis and specifically of the amphetamines, because they are quite prevalent in their use. So let's go into lecture 8, and as always you can always ask questions on the discussion board, and then in lecture 9 as well, as we won't have time to discuss that in class during this week. So there are a number of natural drugs of abuse. The chewing of coca leaves, which we have discussed by various South American groups. The Incas and the Aztecs have done that. And that has been done up until the present. So in Peru and some other Ecuador and some other South American countries, the chewing of coca leaves is still not regulated. It is completely legal. Obviously, anything that involves directly extraction of cocaine and then administering the cocaine in its pure form is considered illegal there as well. Kava kava, some of you have had the experience of trying kava as an extract, and the kava root is the one that has been used traditionally by South Pacific Islanders, and that has spread throughout the South Pacific. And it's really often traditionally used as part of religious, social, or political gatherings, kind of at the beginning in terms of a ceremony that then was kind of calming down the nerves a little bit. So especially if they were opposing parties that often had strong views, it kind of calmed the nerves a little bit and got everybody to finally kind of agree on a kind of compromise. And kava has been shown to have anxiolytic properties, and interestingly enough also a little bit of local anesthetic properties when you use the right part of the plant. And peyote cactus, the buttons, the top, if you slice it off, was used by the Native American church and basically in rituals and ceremonies for millennia, and also up until the present, mainly for hallucinations, for visions, mostly more for an insight for expanding personal visions, but it has certain limitations. So for those of you who have taken use and abuse of drugs, we discussed how mescaline works and in peyote. So we'll go over each of them a little bit and talk about extraction of these compounds in general. So when we talk about natural drugs of abuse, they often serve a particular function. They're not obviously produced by the organism to be abused by humans. And most of them serve a defense function. So they are often created based on an adaptation mechanism in response to environmental threats or to adjust to the environment. So morphine, atropine, cocaine, strychnine. Strychnine is not really abused, although we have discussed it in use and abuse of drugs as a doping agent because it has central stimulant effects if you administer it in the right dose. They all provide protection of the plant against herbivores. So they kind of serve to prevent further destruction of the plant by herbivores, by insects, for example. Bufotenin, which is released from toads, also serves as a protective mechanism against predators. So if you kind of poke the toad or you kind of make it nervous or stress it, then it will secrete this kind of mucus from its glands, and that will cause the predator to usually let go of it, and the predator then will experience hallucinations, and in high doses will experience potentially more severe effects. Psilocybin and mescaline actually serve some communication functions in mushrooms and in the cacti. And if you look at many of how mushrooms are connected with each other through the mycelium, the interconnected hyphae, which often are connected underground. So this kind of white kind of underground network that serves a communication function for the mushrooms. So when we talk about many of these psychoactive compounds or these stimulant compounds and their effects on humans, in response to environmental influences, they don't necessarily serve a function that is natural to every plant or to every to primary functions. They often are, like I said, in adaptation to the environment, and therefore they are often considered secondary metabolites. So they are specific to the environment that the plant or the organism is in. So they are not vital to the absolute survival, but they are adaptive. It's important for them to adapt to that environment and optimize basically their survival. Many drugs of abuse are classified as alkaloids, and what is significant for an alkaloid, what is indicative of a substance being an alkaloid, is the presence of a basic secondary or tertiary nitrogen. So a classical example of that is caffeine. Caffeine contains a lot of nitrogens, and a bunch of them are secondary or tertiary nitrogens. In this case, actually, this one here is the one that is likely the most basic one. These two here are not as basic because they have electron withdrawing groups close to them, and this one is then likely the second most basic one. So these are the two basic nitrogens present. Important to notice also that nearly all alkaloids are bitter in taste. So if you isolate them, nearly all of them will be bitter in taste. Doesn't mean that necessarily the whole extract will taste bitter, but the isolated alkaloid will usually be bitter in taste. So When it comes to the usual extraction, and that's how most of the illicit drugs that are alkaloids are being extracted, we're talking about what's called an acid-base extraction. And basically what is done here, we utilize the property, the physicochemical property of the basic nitrogen and its ability to be ionized and deionized, or protonated and deprotonated in various pH environments. So we use the raw material, plant material usually being minced and then ground up, and to have access to as much of the compound as possible, and then dissolved in water ethanol. And the alkaloids are then mainly present in raw plant materials as actual salts, so they will be ionized in the plant itself because they're usually stored in particular compartments. Most of compounds are stored as a water-soluble form, especially secondary metabolites, because they need to be readily available. Now, if you acidify and adjust the pH to pH 4, then you definitely know that your alkaloid will remain dissolved as an ionized species in the water. And a bunch of the plant parts and particles that do not dissolve in weak acids can be discarded. So you usually just filter it, basically. Then you add a base to it and you increase the pH to above 11, ammonia, and with ammonia usually. And now actually your base will be mainly, your alkaloid will be mainly unionized, because now you reduce the hydrogen ion concentration and there aren't a lot of hydrogen ions in solution. So now it will actually precipitate. And a lot of proteins will also precipitate. And now if you add an organic solvent to it, because it is now basically not soluble in water because it's precipitated, your alkaloid will be extracted into the organic layer. And that's how you separate out the alkaloid from the rest of your mixture of all the other crap that you really don't need. And you go through this repeatedly in order to purify the desired alkaloid or alkaloids, because sometimes you might have multiple ones in your mixture. There are often, like for example with morphine, you've got codeine in there, you've got thebaine in the raw opium. So that's how you get raw opium. And then you have to adjust very carefully the pH. So you need to be somewhat careful if you really want pure morphine in the end. But this is basically the steps that you need to go through, multiple of these pH adjustment steps, and then you need to kind of narrow it down and tweak it a little bit in order to get the specific alkaloid of interest by adjusting the pH to that particular pH range where only your alkaloid will be precipitating to dissolve it in the organic phase then. So that's for alkaloids. So why do we want to extract them? And that kind of harps back to the natural use versus the abuse, actually. So when we compare traditional uses of naturally occurring drugs, often we use routes of administration that are very different from drug abusers. So cocaine leaves are being chewed or prepared as a tea. The effectiveness of delivery and the amount of cocaine that we can deliver via that route is not really what a drug abuser is looking for, because it takes a long time. Even with chewing, you don't get a lot of cocaine into the CNS. It helps usually to stimulate breathing. It might be a slight stimulation, but it's not nearly close to what you want to get when you really get high. Peyote buttons are also mainly chewed, so really getting high on them, yes, you get kind of this psychoactive behavior, this psychoactive effect after a while, but it's not a very pleasant gastrointestinal effect that you get initially. Opium is a thick sap that is taken orally, and it's not really used to get high. It's mainly used as an analgesic and for diarrhea. So it's the traditional routes are not really that effective if you want to abuse the drug. So it's relatively ineffective in terms of delivery, and much of the active compound is not utilized. It doesn't get you high. And there are side effects, diminished potency. So when you look at morphine, it's an alkaloid present in the unripe seed pods of the opium plant. The initial milky extract is referred to as opium and is a very thick sap that quickly darkens, and that's mainly due to oxidation that happens. The milk sap contains a bunch of side products that are not wanted or not really of interest to us. And sometimes this is also referred to as black tar. That's a pre-processed form of opium that has been dried. Opium tincture is an alcoholic tincture or extraction of opium, and that can contain up to the 10% morphine. And 10% morphine is usually also what you can find in raw opium. So it's really a very concentrated extract of opium, of raw opium. There are a number of different extracts that were available. Laudanum is one of them. That's an alcoholic tincture that still contains 10% opium and approximately 1% morphine. It is still available here in the United States as a prescription drug, although I doubt that many people will still see it prescribed. So this is a distinction between the opium tincture. This is an opium tincture that contains 10% morphine. Laudanum is an alcoholic tincture that contains 10% opium. So you kind of go gradually less concentrated, so to say. Paregoric is actually a kind of mixture of different things. It's one of these old patent medicine that somehow survived it, which contains a mixture of anise oil, benzoic acid, camphor, and glycerin, and also opium. So it's really mainly used for diarrhea, cough, and mild pain. And actually, this one is not used and banned by the FDA, but it initially survived the patent medicine process. So when we look at how morphine is being used, and obviously this is very similar to how heroin is being used, because both of them still contain the tertiary nitrogen. So you can, when you inject it, you have to ionize it, you have to protonate it. When you have the morphine base, which would be non-protonated, you have to convert it into the hydrochloride salt to be soluble. So many illicit drug use often requires additional vitamin C or vinegar to make a solution more acidic. So you will often see spoons, and then you add a little bit of vitamin C, which is acidic, or vinegar to it. Vitamin C might be a better way to go for injection, but people are desperate and they will use pretty much anything that they can get their hands on. Obviously, repeated use of the same needle can lead to infections, or if you do any needle sharing, hepatitis B, hepatitis C, HIV, all of that can be transmitted very easily as well. So when we look at cocaine, that's an alkaloid found in the leaves of the shrub Erythroxylon coca, which doesn't grow here in the United States because it needs a high altitude, and it's sold naturally and completely legally in certain countries, the dried leaves. Traditionally used as a tea or being chewed relatively briefly. It's not chewed on for very long, but the effects actually, buccal absorption, last relatively long. Can be used against nosebleeds, locally applied. Obviously local anesthetic effects, as we discussed before. Even the the buccal absorption is not providing the high that drug abusers will experience from it. Sometimes it is mixed with small amounts of specific ashes to make it more basic in nature and therefore allow for a higher amount to be absorbed. A quinoa plant and make it more palatable, cane sugar and aniseed is provided. Baking soda to activate the alkaloid. And I mentioned that frequently cocaine was actually the initial ingredient in Coca-Cola, and coca leaves are still imported by the Coca-Cola company. Freebase cocaine can be snorted or inhaled because the base obviously can very well penetrate through cell membranes. But over the long run, this really leads to destruction of the nasal mucosa. The so-called cocaine nose may evolve, dry nasal mucosa, loss of nasal mucosa with repetitive use because you constantly constrict the blood vessels in the nasal mucosa, and that leads to desensitization and eventually really it's basically like cauterizing your blood vessels because they're so heavily constricted that it's really very destructive for blood vessels. Crack cocaine is also freebase cocaine, and that can be smoked. There's a crack pipe, and usually when you inject it, you want to use a little bit of baking soda with a teaspoon to inject it. It's still water soluble, although sometimes it's a messy endeavor. We use the same extraction method for cocaine that we use for morphine, the acid-base extraction. Peyote is a blooming cactus, Lophophora williamsii, native to southwestern area of the United States, Texas, Mexico, Arizona, New Mexico. So the Sonoran Desert that spreads through the north of Mexico, and then the south of the United States is Arizona and New Mexico is really where peyote cactus can be found. There are other cacti that also contain it, but not in the same amounts. So the peyote cactus is the primary source for that particular ingredient, mescaline. So it has quite a long tradition in the Native American culture, specifically in the Huichol region. I probably mispronounced that. It's one of the four principal deities derived from the sun god. So here you see it actually depicted. The other three are the eagle, the blue deer, and corn. So it's primarily used as in rituals, in religious ceremonies, or to basically instill kind of a state of insight and inner reflection. The principal psychoactive alkaloid in peyote is mescaline. If you look at mescaline, you have here a primary amine, and even that one can be potentially extracted, but it's not really done. So you won't find a lot of street mescaline out there. I have never really heard about that. In order to actually get the effect of really getting high on mescaline, 200 to 400 milligram mescaline, you need to ingest 10 to 20 gram of dried peyote buttons, and then the effects last for quite some time, 10 to 12 hours. So it's more an introspective, dreamlike state. Interestingly enough, if you look at the structure, it mainly acts on serotonergic receptors, similar to LSD. But you also compare it to dopamine and epinephrine, it also has some interference with dopaminergic neurotransmission, and minor, but very minor, with epinephrine. But dopamine definitely, so it has some potential to increase also heart rate and some reward, and that's probably primarily why it is regulated. And obviously the whole psychoactive interference. So orally ingested, it has a slightly acidic taste, like raw potatoes. I don't know what raw potatoes taste like. I've heard that you shouldn't eat them raw, something left up for discussion. It's not really, like I said, it's not really abused in any other way or form, because mescaline is seldomly extracted. Usually it would follow the same acid-base extraction principle, and then you would also have to remove quite a bit of fat, which is present actually in the cactus. Peyote has an exception. The use of peyote has an exception by the DEA. Otherwise, peyote is regulated in Schedule 1 together with mescaline. Many of the physical effects may be similar to that of LSD, with hallucinations, usually much longer lasting, and it has more toxicity associated with it. Many of the initial symptoms are gastrointestinal, so people might throw up. Nausea, vomiting are very common for the first 1 to 2 to 3 hours, and then really the insights are, and the psychoactive component will come through. In the past 10-15 years, we've seen an increase in the abuse of nightshade plants, the Solanaceae. Not necessarily tomatoes or potatoes, but some other ones that belong to the same family. Angel's trumpet, for example, Brugmansias, sometimes henbane, or even devil's trumpet, Datura stramonium. This is Datura. This is, where do we have it? Here is Angel's trumpet, and this would be henbane. Here's Nicotiana, and here is the deadly nightshade. So we have many vegetables in that same family: tomato, potato, eggplant, chili pepper, that belong to that same family. And they are producing some of these compounds, but they are not exerting the same effects. But many of the anticholinergic substances that we discussed in IS2 are actually exerting these effects. So it's important to look out for that. Tobacco is one of the most used, misused, abused drugs in the world, and actually named after the French ambassador to Portugal, Jean Nicot, who sent tobacco as a gift and medicine to the Queen's court there in Portugal. Nicotine. Nicotine is a central nervous system stimulant and acts on endogenous acetylcholine receptors as an agonist, as we know, with both CNS and peripheral effects. Now, nicotine itself, we know what its effects are. You know that from IS2 and from your own reading and potential interactions. But many of the anticholinergics are competitive antagonists at muscarinic acetylcholine receptors, and especially atropine, hyoscyamin, scopolamine. We know that it has this long history of being used both as a poison and as a cosmetic because it causes this mydriasis. It can last for hours. Chronic use may lead to blindness. Belladonna means beautiful woman. You guys all remember that probably from IS2. And atropine can cause hallucinations. How exactly that happens, we don't know, but it might be linked to the muscarinic antagonism that then actually translates to serotonin receptors. So there must be some connection with serotonin receptors. So there are various routes how this may happen. Has been proposed because it has been observed that teenagers, young adults are smoking the leaves or preparing teas. And it's obviously very hard to dose that. You don't really know how much you're taking and where the dose is, where it's getting dangerous. 1 to 2 berries from Atropa belladonna are lethal to kids, 5 to 7 for adults. So you can kind of play a game of Russian roulette if you're trying, maybe 3 berries for an adult and I can get high. And I can tell you if that's the right thing to do or not. The angel's trumpet seems to be favored for some reason. I don't know exactly why, but there have been a number of case reports and series of case reports with severe hallucinations and anticholinergic toxidrome. You might remember that dry as a bat, mad as a hatter, dry as a bone, blind as a bat, mad as a hatter, and all of that stuff with anticholinergic toxidrome. So that has been kind of occurring over the past 10 years or so. If you look at atropine, hyoscyamin, and scopolamine, they all also have a tertiary amine here, and therefore they possess CNS activity and are anticholinergics and can therefore induce the anticholinergic toxidrome. Hot as a hare, blind as a bat, dry as a bone, red as a beet, and mad as a hatter. So here are a few drugs that I would like to discuss that are a little bit of outliers. Mariana is one of them. We've discussed it before, just in the last lecture. That's Mariana derived from the dried flowers of the female plants. The main psychoactive compound is delta-9 tetrahydrocannabinol, and that acts on the CB1 and CB2 receptors. What's interesting here is that this compound does not contain a basic nitrogen. It doesn't contain a nitrogen at all. It acts on the cannabinoid receptors, and the CB1 receptors seem to be the ones that are mainly responsible for the CNS effects, for potentially the hallucinations, as well as for the pain relief and some of the other beneficial effects. We don't really know yet what the CB2 receptors might provide. There's some indication for immune cells. So if you use a CB2 receptor agonist or antagonist, there's some discussion about that. Now, traditionally, Mariana has been used for meditative purposes. It has shown some value in chemotherapy-induced vomiting. Marinol and dronabinol are both, used as THC isolates, but the effects are different from the smoked plant extract. So there might be something to some other compounds in it. Cannabidiol has been attributed to some effects as well. And as I said, we cannot use the traditional, or what I discussed before, the acid-base extraction to get to THC. So here we would have to use a different extraction method. And mostly that is usually a rather alcoholic extraction. So because it is rather lipophilic, we would mainly use ethanol to retrieve kind of a brown raisin-like fluid. So after evaporation of the ethanol, we kind of get this very thick kind of syrup-like brown fluid. Now, with more sophisticated techniques, and obviously the Mariana and the pot industry kind of really gaining some steam in the United States and also internationally. There are more advanced techniques such as critical fluid extraction or CO2 extracts. And this has been working very effectively for a number of other extracts, most notably for coffee extracts. Depending on how strong or how caffeinated the extract needed to be. We have seen CO2 extracts and supercritical fluid extractions there as well. And therefore we can really kind of control a little bit how much THC, how strong these extracts can be. And that has yielded significantly higher THC concentrations than were available with ethanol extracts. And that's why we see sometimes very strong THC extracts that are up in the 25, 30, 35% THC, which hasn't been really the case up until maybe 5-10 years ago. So hash oil basically is a very highly concentrated THC extract. Often it's basically mixed with an oil that is non-volatile and contains somewhere in the range of 40 to up to 70% THC or cannabinoids. So it's very highly concentrated. The advantages of using hash oil over just pot extracts or weed or whatever you want to call it, it can be easily concealed because it's just a small container with sometimes a yellowish kind of fluid in it. You also don't get the pot smell because the cannabinoids itself are not linked to the sweet smell of pot that one might smell. Healthier since it is not inhaled with some of the other smoke ingredients, smoke components that are usually found in Mariana. It can be ingested, so you can drop it on edibles, in yogurt or something like that, or it can be directly rubbed on the buccal lining. Like I said, very high THC content. The disadvantage here is you can also still just add it to regular cigarettes and smoke it, and therefore it can be very well concealed that way. You might just then be disguising yourself as a regular smoker. And obviously the risk of overdosing with prolonged and significant side effects, hallucinations and arrhythmias. I mentioned that that there is a risk that one might experience hypertension. Heart rate increase has been observed with the use of Mariana and pot. Another non-nitrogenous drug of abuse, naturally occurring drug of abuse, is Salvia divinorum, or the active ingredient it is non-nitrogenous. It's also referred to as diviner sage, and that has gained some interest in the drug abuser community as well as by the legal oversight entities. Maybe even in the past 10 years, and especially among college students. It looks almost similar when the plant is small to regular sage, but it can grow to a shrub or even to a tree here. If you compare it here, that's not how regular salvia looks like. The main active psychoactive substance in it is salvinorin A. And I'll show you the structure in just a second. Salvia divinorum is primarily smoked and creates a very intense and short-lived high. If you go on YouTube and you search for Salvia divinorum trip or something like that, you will find some very intense and interesting stories about it. So Salvinorin A is really a unique hallucinogen, and it was kind of rattling the scientific community at the time, that it was structurally elucidated and then also its mechanism of action revealed. Once again, if you look at it, it does not contain a basic nitrogen, or any nitrogen for that matter, so there's no nitrogen at all. See a bunch of esters in here, you see a lactone in here, furan ring system, but no nitrogen. It does not interact with serotonin or dopamine receptors, like all of the other hallucinogens do. And it actually binds to the kappa opioid receptor as an antagonist. And that has kind of really roiled the community for multiple reasons, the scientific community. So it was the first non-nitrogenous opioid receptor binding agent. Before that, we always assumed that any agent that interacts with opioid receptors requires a nitrogen, a basic nitrogen, to interact with the receptor, because that binding fold has always been seen as vital to the interaction. And second, we always thought that we need some activity at serotonin or dopamine receptors in order to see hallucinogenic activity, usually serotonin receptors. So antagonism at kappa opioid receptors was really stunning. Now we get a little bit more further downstream and observe a little bit more what does actually antagonism at kappa opioid receptors cause, and high selectivity for kappa opioid receptors cause. And there have been some observations that point in the direction that there might be some benefit to that in terms of treatment of depression, for example, and also targeting specific opioid receptors in regards to treatment of pain. But one hindrance is here that Salvinorin A is now actually being scheduled, so that hinders obviously research that can be done. But it's still fascinating. There are other salvinorins that have also affinity for the kappa opioid receptor, and beyond that for other opioid receptors. So it's still a fascinating natural product that hopefully will still be able to be researched in the future. So Salvinorin A has been proposed to be put in DEA Schedule 1, and several states have already placed it in their respective Schedule 1. And actually the current update is that nearly all of the US states have placed it in emergency scheduled in Schedule 1. The issue here is that it is not likely to be used frequently by folks. So those who have had a Salvia divinorum trip usually are not likely to use it over and over again, because the trips are so dissociative in nature, and for most people who are using, so scary that they are not interested in using again. So not likely that it's going to become a major drug of abuse. But there might be treatment options for it, uses. So for schizophrenia, depression, and post-traumatic stress disorder, for example. So that's where some people are looking at it. Once again, since it doesn't contain a basic nitrogen, we cannot extract it from Salvia divinorum via acid-base extraction. So we have to look for other ways, and here it would also be likely a careful non-polar extraction, so similar to THC from Mariana. So one big issue is if you have one Mariana plant at home, or even one Salvia divinorum plant for your own personal use, it is not necessarily that likely that somebody is gonna come after you, because for one, the costs are not going to be outrageously high. But if you are actually farming and for your own harvesting and then distribution, then you will see significant rises in costs, because maintaining some of these plants, especially when it comes to marijuana, can get quite expensive. You need a particular environment for them. They need a lot of light, so energy costs are going up, electricity, water costs, all of that stuff. So you might get on the radar at some point. So coca shrubs and opium flowers are not likely to really do all that well in the United States. Have been really small indications of that here and there, but they're just not doing all that well. So most of that is really imported. There might be the occasional opium plant for self-sufficient use that may be observed. Maybe somebody just plants it somewhere in their garden if they can get a hold of seeds or something like that. Now, Mariana requires a very moist and warm environment and a lot of space. So usually basements are being used for that, and darkened windows or stuff like that. So sometimes it's either a basement or it's grown out in the middle of nowhere, California, or sometimes it's like a storage facility or something like that. Mushrooms are often grown in basements because they require darkness and moist environment, and they have this sweet and rotting smell to them. So that's an indication that usually somebody might be having mushrooms, unless they have mold somewhere in their basement or in their home. Cacti obviously require sunlight. Sometimes they might be just interspersed with regular landscaping, hidden as ornamental cacti. Some people might not even be aware of it. The most common ornamental plant here in Arizona that is highly toxic is now it escapes me myself. Is oleander, are the oleander trees and shrubs that we have here. Highly toxic, and they also are used, they can be used in very low amounts to get high, but they're mainly used for their antiarrhythmic properties, and only a little bit of overdose will usually cause you to have arrhythmias. So yeah, they look pretty and they grow very nicely, but not a good thing to have around your kids. If somebody purchases large amounts of fertilizers, high in minerals, especially potassium, magnesium, and calcium, usually a pretty good indicator that they likely will have marijuana around, because they really eat it up. Also high proof medicinal alcohol, because that is often used for extraction procedures, especially if they really stop by and they request not isopropyl alcohol, but they need medicinal alcohol 190 proof or 200 proof. So some of the illicit farmers grow in rural areas and away from neighbors. Obviously, you want to stay away from it. For cannabis sativa, you can use greenhouses. I said Erythrocyrum coca really doesn't grow here all that well. Maybe to some degree in Colorado at higher elevation you might be able to grow it. Salvia divinorum growth is very prevalent in more subtropical regions. Florida, California, more likely there. Whole fields, like here in California, for example, cannabis sativa in remote areas, they just growing out in the middle of nowhere and hoping that nobody will notice, basically. So yeah, that's how it's done. And then sometimes they have to basically cut it down. The DA comes in, cuts it down, and just burns it to the ground. So that's it for lecture 8. We are actually, wow, didn't do too bad. So the lecture 8 quiz is Black Panther. It's gonna come out in movie theaters on February 16th, and I'm excited. I'm gonna go directly on the day it's opening. Please remember, you've got 15 minutes to answer all 5 questions. The quiz is going to stay open until Monday, February 12th, the end of day, and the discussion board also, your post to the discussion board for lecture 8 also has to be posted before the end of the day on February 12th for full points. Okay. If you have any questions about lecture 8, please post them separately from your required discussion board post to the discussion board for lecture 8. Otherwise, we shall discuss it in class on February 13th for lecture 9. Until then, I hope you can enjoy the rest of your week, and see you then on February 13th. Take care, everybody. Bye.